So here is question 3. All right, very straightforward question. Normally these questions are very nice. Your 3 marks, and this is where you should get actually full marks. So first of all, let's do this, right? So we're going to underline all the important information, and then we're going to put all of the information on the sketch, and then we answer our questions. Because remember, we need the information in order to answer basically all of these questions. So in the diagram below, HS and TB are diagonals. So HS and TB are diagonals of the parallelogram, which is HTSB, which is this entire parallelogram over here. First of all, before we go on any further, we need to note our properties of our parallelogram, right? We know that the opposite sides are parallel to each other. Pairs of opposite sides are equal and parallel to each other. So therefore, this would be parallel to this, and this would be parallel to this. And then these diagonals over here would be, this would be equal to this, and then this would be equal to this. And therefore, this would be the midpoint of these diagonals. So that is what our properties would state over here, right? Okay, so now where do we start? So we need to still read the information here, right? So it says here, HS and TB intersect at M, which has the coordinates 1 and 2. So we already said that that is 1 and 2 over there, right? TB intersect the X and Y axis at the origin. So they're saying the origin is over here, which the origin is 0 and 0. Okay, cool. And that is our coordinates of O. So we have T, which has coordinates of X and 6, and then S has coordinates of 4 and 1, right? And those are vertices of HTSB, which is our parallelogram. And then they say that the angle MTS is equal to alpha. So alpha is equal to angle MTS. Basically, that's what they're telling us. All right, cool. And also TB is the inclination angle, or the angle of inclination of TB is theta. Over here, there's theta, and for TB, that is the angle of inclination over here. It's an angle that is going upwards from left to right. Okay, now, where do we start here? Because we put down our properties of a parallelogram, what we need to do is now we can actually answer the questions, right? So we need to determine, for 3.1.1, we need to determine the equation of line TB, which is this line over here, in the form of y equals mx plus c. Okay, so first of all, whenever we want to get this stuff into the form, so we're going to have it's actually 3.1.1. that says the following. So we need to get into the form of y equals mx plus c, where we say that we want to find m and c. Okay? So, first of all, right, we can clearly see that the y-intercept is actually going to... So first of all, we know that our c value here is just going to be equal to 0, right? So we already know that this c is not going to be there, right? And the reason why this is true is because it's passing through our origin. But for now, let's not focus on that, because I'm pretty sure you guys have learned to first find the gradient. So we're going to find the gradient first. And the gradient we know, so the gradient of TB is going to be equal to, because remember we're working with line TB, and what information do we have? Remember, we must have at least 2 points. So we have M, which is 1 and 2, and we also have, and remember over here, here's another point, and we are given this point, but we're not given the x value. So we're going to use a different point. We can see that the O is also lying on the line TB, so we're going to use the point O as well. So we're going to have line O, which has the coordinates 0 and 0. And now we're just going to name them after their sets. So this is going to be set 1, and this is going to be set 2. So coordinate M is set 1, and coordinate O is set 2. Sorry, I should just write the 2 over here. Such that this x coordinate will be x1, this y coordinate will be y1, this x coordinate will be x2, and this y coordinate would be y2, named after their sets over here. And now, because we have that information, we can use our formula, which is y2 over y1, sorry, y2 minus y1 over x2 minus x1. And then therefore here we can say that the gradient of TB is just going to be equal to our y2, which is 0, minus our y1, which is 2, all over our x2, which is 0, minus our x1, which is 1. And then therefore we're going to have an answer of 2. The gradient of TB is equal to 2. And then now we can actually plug into our equation here that we have y is equal to 2x in this case, right? So that's our equation. And what I want to say over here, just note that whenever it passes through the origin, right, your y value will automatically, or sorry, your c value will automatically be plus 0. But we don't have to include the plus 0. If you did include the plus 0, they're not going to mark you off because it doesn't really make a difference. But it's going to be 2x in our case over here. And that is how we determine the equation. Now let's move on to the next question over here that says the following. 3.1.2 says find the size of theta. Okay, so this one is also an easy one. Also note how I don't have the marks over here. The marks are actually here. I'm not really paying too much attention to the marks because I think that the most important part about all of this is actually to understand what we are answering, right? So then there's not just like, oh, this mark goes here and all that. Of course it works like that, but we want to actually, all we want to do is just, we know what we're doing. That's what we're trying to show the teachers. Otherwise, if you do forget about something, then try and get as much marks as you can so that you have a higher chance of getting amazing marks, especially for questions like these. It's really, really simple and straightforward. So size of theta, we need to determine what is this. Okay, what is the size of theta? Now, first of all, what we have over here, I'm just going to draw it like this, right? So we have, let me just do this over here. We have 3.1.2, which is going to be the following. We have the size of theta, which is just going to be equal to, so we're going to have this the following angle over here, right? Or let me just do it like this. We have our Cartesian plane, and we have the angle theta here. And then we have a point M somewhere over here that we know. The reason why I'm using M is because we know it. It's 1 and 2, right? So M is 1 and 2. And now we know that if we can construct the lines over here, so we know that this vertical line is parallel to this line over here, then we can say that this is going to be the y value, which is 2, and this is going to be the x value, which is 1. So this is the x and this is the y. Okay, and when we are finding the angle over here, right, we need to have known values, right? So we're going to use what values do we know for theta, right? We know the adjacent and we know the opposite, right? So therefore we're going to use the ratio of tan of theta. Opposite over adjacent. The opposite is equal to 2 and the adjacent is going, let me just write this down. So it's the opposite over the adjacent, which is equal to our opposite, which is 2, and our adjacent, which is 1. And then now what over here, we know it's just going to be the angle theta is going to be equal to, it's going to be arctan of 2. Remember that this 1 can fall away because 2 divided by 1 is just 2. And then therefore, theta is just going to be equal to, if we put it on a calculator, it's going to be equal to 63,43 degrees. Okay, and let's actually first check. Okay, so it is in quadrant 1, right? So therefore, we know that quadrant 1 is just going to be theta on its own. If it was in quadrant 2, you would say 180 degrees minus theta. If it was in quadrant 3, then it would be 180 degrees plus theta, or it would be 360 degrees minus theta in the fourth quadrant. Okay, so just keep that in mind, please, over here, based on the different quadrants that we have. Okay, now we're going to answer 3.1.3. So we've answered 3.1.2. We need to determine the coordinates of h. Now, thankfully, what we have over here is the information from our quadrilateral, right? So the h is over here, and we have the coordinates of M and S, right? And we know that this length is the same as this length over here of this diagonal, and therefore M would be the midpoint, right? So from this one over here, what we have to say is, so first we have to actually state that M will be the midpoint, right? So it would look like this. Actually, now that I look at it, you don't actually have to state that it's a midpoint. Sorry about that. I just had to like think over here. What? You really need to state it, because otherwise you're gonna have to like go deep through like some terminology and say, oh, this property. But yes, we know it's a midpoint, right? So therefore we use the reverse midpoint formula. So this is how it's gonna look, right? So we are looking for h, right? And we're gonna name our variables of h. It's gonna be x3 and y3, right? And then we know that we have M, which has the coordinates x1 and y1. And then we also have, so it doesn't matter which one you name it, as long as you find the coordinates of h, right? But I'm just naming these ones. And then it's not O. This, let's just say S is set 2, basically. So S has the coordinates of 4 and positive 1. Alright, now we have to use the reverse midpoint formula, which says the following. We have, it's going to be x3, so x subscript 3 is equal to x subscript 2 minus the x subscript 1 all over 2. And we have y subscript 3 is equal to y subscript 2 minus y subscript 1 all over 2. So essentially it's just this. Can you see that this is basically this over here? I'm pretty sure, wait, hold on, give me a moment. Okay, I referred back to my formula. It's not minus, sorry, I got the gradient confused. I was thinking now, that does not look right. Just note that it's actually the midpoint formula, but this time we're making our own equations. We're separating it. So you can see this is on the one side from the x, and then this is on the other side for the y, right? But in this case, we actually just added our new variables. Okay, anyway, so now we just need to solve, right? Or we need to substitute first. We have x subscript 3 is equal to, and we have x2 plus x1. x2 is just going to be, sorry, why am I going all the way here? This laptop is really not all there. I actually should have just labeled this as it was. So it's actually M has coordinates of 1 and 2. And we call this x1, x2. And let's call this x2. This is y1. And this is going to be y2, right? And now we need to find out what is our x3. So we need to use our x1 and our x2. So x2 is equal to 4 plus x1, which is equal to 1. Remember, the order of these two x's doesn't matter, because remember, it's a plus. It's commutative. So it doesn't matter which order you put in. Okay, and then this is all over 2. We say and y subscript 3 is equal to y2, which is equal to 1, plus y1, which is equal to 2, all over 2, right? So therefore, we'll have y3 is equal to 3 over 2, and we'll have x subscript 3, which is equal to 4 plus 1, which is 5, so 5 over 2. And then therefore, our coordinate of h will be 5 and 2 and 3 and 2. 3 over 2. Sorry, not 5 and 2. 5 over 2, and the y coordinate would be 3 over 2. And there's our answer for h. So 3.1.4, whoa, hold on, 3.2 actually. So it was 3.2. It says the following over here, right? So 3.2 says over here that show that the x coordinate of t is 3. So we need to prove that this is going to be equal to 3. If it is further given that ts is equal to root 26, okay, come on, this is really easy. So basically they tell us what the length of ts is equal to, and s, they do give us the other coordinate, right? So we have the following information. T is going to be x and, I believe it was 6, and then s would be s with the coordinates of 4 and 1. So this is what we are going to do, right? So we have the following formula where we have the length of ts is going to be equal to the square root of, so we're going to deal with the the x first, so it's going to be x2 minus x1 all squared plus y2 minus y1 all squared, and then this is just the root all over. Now they tell us that, remember from the information, they say TS is equal to 26. Sorry, root 26. So we have root 26 on this side over here that we have to replace with. And now we just have to substitute for the rest of them. So let's just say that the following, right? Remember, we need to name our coordinates. So our coordinates over here, we're going to name this set 1. And this is going to be set 2. So therefore, this would be x1. This would be y1. This would be, let me just move this a little bit up here. This would be x2. And this would be y2. Okay. So now our x1 is going to be, our x2 is going to be 4 minus the x1, which we are trying to find, which is equal to x, right? All squared plus, and then we have y2, which is equal to 1 minus, and then y1, which is 6, all squared. Okay. All right, cool stuff. Now what we're going to do over here is, remember we have root 26, but what we can do over here is we can square both sides such that the roots will cancel, and then we'll be left with 26 is equal to, then we're going to have 4 minus x all squared plus, we know over here that 1 minus 6 is equal to negative 5 all squared. Okay, now we just need to simplify even further. We have 26 is equal to 4 minus x can also, all squared is just going to be written as 4 minus x multiplied by 4 minus x plus negative 5 squared is just going to be positive 25. Because there's a square, it's going to be positive. Now we can just do this. We can just use FOIL method. So it's going to be 4 times 4, which is 16. Then it's going to be outer, so it's going to be minus 4x. Then it's going to be minus 4x. And then it's going to be positive x squared. And then this is going to be plus 25. And we can see this is going to be a quadratic. So we're going to minus both sides by 26, such that these will cancel. And then we'll have minus 26 on this side and 0 on this side. And now we just have to deal with like terms. So we have x squared here on its own. So it's just going to be x squared here. And then we have the x's, which is going to be minus 4, which is minus 8x. And then we're going to have all the constants. And this is going to be 25 minus 26, which is equal to negative 1. Negative 1 plus 16 is equal to positive 15. Okay, now what we have to do is we just need to solve for our x values, right? And we need to see which one we're going to be using. All right, so from this point here, we just need to factorize. So we have 15, which has factors. We need to get factors that give us an 8. So we have 3 and 5, and we have 1 and 15. So what we can clearly see is 3 plus 8 will give us 8. Sorry, 3 plus 5 will give us 8. So we can use factors of 3 and 5. So it's going to be x. The negative goes to the biggest one, which is going to be minus 5 over here. And then we're going to have a negative, and a positive gives a negative. So it's going to be x minus 3. And therefore, we're going to have x is equal to positive 5, or x is equal to positive 3. So here, we have two values. Now we need to choose which one is correct, because we can't have two values for x, right? So we need to see where t is placed. So could it be 3? Well, let's just look at this, right? Could it be 3? Okay. It actually, I remember now from the question, it says here that prove that it is equal to 3, and there we go. So therefore, it cannot be equal to 5, and therefore, x is equal to 3. So there is the answer for 3.2. Let's move on to the next one. I hope you like my setup, by the way. So I'm keeping the answers right over here on the left hand side, and the right hand side here I'm going to be solving for these answers. Okay, so we're done with question 3.2. Now let's do 3.3. So 3.3 says calculate the angle alpha, which is the size of MTS, which we said in the beginning over here. So alpha is over here, and we know that this new coordinates of t is going to be 3 and 6. Okay, so now that we have that information, we have to do the following, right? Okay, so I sat on this one for a little bit, but I realized what we should do. Okay, so for this one over here, we have calculate the angle. Okay, so alpha, I already said, calculate alpha, and then that is the size of MTS. Now, the first thing you need to do, right, so there's not really much information to give us this angle, especially that it's just random somewhere in the Cartesian plane. But what we do know from our lessons, and that's why I'm saying paying attention in class is really important. So we need to define and we need to extend one of our lines such that we can find this angle in a chain, not a chain method, in like, so we're going to basically prepare to find this angle right here. And how are we going to do that? So we can clearly not create or extend a line from here, because we can clearly see that over here, it's going to give, then we'll be looking for some angle over here, right? But what we can do is we can actually extend a line all the way through here. That is not a straight line. We can extend a line all the way through here, right? Such that we will have an angle that is going to be from here, and then we're going to have it corresponding here to our, not corresponding, sorry, it's kind of alternative to our alpha over here, but not exactly alternative, because obviously we need to consider that we would have had like parallel lines, and then we had to do all that stuff. The reason why I'm going to extend the line here is because we need to extend a line such that there is a horizontal line involved, or if there was a vertical line involved, then we could also do that. But in our case over here, we have a horizontal line, and then we need to find this angle over here. And once we find this angle here, we can actually then determine our alpha. Right? So now I'll show you the step-by-step process. So what I want to do is I want to name this variable over here, this angle. But we already have theta, we have alpha, and therefore we can use the angle beta. So let this angle be equal to beta. Right? You would just do that on your question paper or your worksheet. Okay, now from this point over here, what we're going to be doing is we're going to find out what beta is. Now the first thing we need to do, because we have a straight line and we know 2 points over here, so we have this straight line, we extended it over here, we know 2 points of the straight line, so we need to find the gradient of TS. So therefore the gradient of TS will be equal to, then we're going to have the, okay, so it's going to be the y2 minus y1. So we're going to name our sets over here. We're going to name, let's say, S will be 4 and 1. And then we're going to have T, which is going to be 3 and 6, right? And then we're going to name them after their sets. So we can say that S is set 1, so this will be x1 and y1. And this will be x2 and y2 because we're naming this set 2. So it's going to be set 1 here, and then we have set 2 over here. So our y2 will be equal to 6 minus our y1, which is 1, all over our x2, which is 3, minus our x1, which is 4. And then over here, what we're going to be doing is we're going to determine the gradient here of TS over here, and we're going to simplify. So 6 minus 1 is 5, and then 3 minus 4 is just going to be equal to negative 1. And therefore, you're going to have the gradient of TS equal to negative 5. And now from this point over here, now we can find our beta. And because we subtended this new line, we can actually take the tan of our angle, or sorry, of our beta. Not our beta, our gradient. So it's going to be the tan of our, so it's going to be tan beta, sorry, is going to be equal to that gradient that we determined. Because that was what we have created so that we can actually get towards our answer, which is alpha. So we have tan beta is equal to negative 5, and then we have, we need to arc, we have to arc the tan over here, so it's going to be arctan of negative 5, which will actually give us an answer of, if we arctan of negative 5 here, we're going to get an answer of negative 78, 690 ... degrees, right? Now remember, what do we have over here? Let's try and see something, right? This is obviously an obtuse angle, and let's look at where it's situated, right? Let's create our own quadrants here, the Cartesian plane, such that this would be in line with the y, parallel to the y, and then we have the x-axis over here, right? So therefore, it surpasses, it's basically going to be either 90 degrees plus the theta, or it can actually be 180 degrees minus our theta. The reason why it's 180 degrees minus our theta is because it's an obtuse angle, and that is what we know about our obtuse angles. It is greater than 90 degrees, or it is less than 180 degrees. And that is why we look at it like this. But over here, what we are actually going to do is we're going to say, therefore, beta is going to be equal to, so our negative 78,690 dot 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 theta, and we're just going to add 180 degrees here. Remember, over here, that's what you're going to do, because we don't want a negative answer over here. So therefore, our beta will just be equal to, and then we're going to get an answer of 101, comma, 309 dot 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 degrees. Okay guys, so I do apologize for my terrible explanation, but let me go through this explanation with you, right? So I should have explained it like this. So we have our Cartesian plane over here, right, from our diagram, and we have the following angles. It's going to be theta, and then we have alpha, right? So it's going to look something like this. It's going to be theta like this, and then we have alpha going down like this, right? So let me just do this. There we go. Okay. So here's our alpha, and here's our theta, and then we had this triangle going back like this, right? But our theta, oh no, it wasn't going back like that. Sorry, it was actually going back like this. So it was going somewhere here, right? Such that it was parallel to that. But that's not important here. What we did in our case over here, just to guide you here, right, is I extended the line like this, right? I don't know why I didn't explain it properly. My mind just was all over the place. The reason why I did this angle over here, now that you can see it clearly, I created this angle beta because this is our exterior angle, right? Our exterior angle. And we know that the exterior angle is the sum of the two opposite interior angles, right? So beta would be equal to alpha plus theta, right? And in this case, we are actually trying to find our alpha. So we're going to make alpha the subject of the formula. We are going to minus both sides by beta. Or no, sorry, we're going to minus both sides by theta. And therefore, we're going to have alpha is equal to beta minus theta. And now, if we were to continue over here, now that I've shown you what it looks like, and we can even go back here, it looks exactly like that. This fly is really messing around with me here. We have this over here, and that is exactly what we have there. Exactly what I just shown. So, now that we know our beta and our theta, remember we also determined our theta, which was equal to 63,43 degrees. And therefore, what we can do is determine our alpha. And then now we can write it like this. Therefore, alpha, I'm just going to write the answer here. It's going to be alpha is equal to 101, 3099, something degrees. Something degrees because it goes on. And it's going to be minus our theta, which is, I think it was, I can't even remember, 63,43. So it's 63,43 degrees. And then therefore our alpha will just be equal to what we have over there, minus 63.43. What happened to my answer? Minus 63.43. And that is just going to be equal to 37,88 degrees. And that is our value of alpha. So now we're going to do 3.4. I don't have to take long with this one. This is a very straightforward one. So BTS, where's BTS? So B starts here, and it goes all the way to T over here, and then S over here. Okay. And then it fills up the triangle here. Okay. Now, we need to determine the area of that, right? So if we were to write the triangle as this way, right? So I'm gonna orientate the triangle such that it looks like this. It's gonna look like this. It's gonna be we have the base of the triangle, which is going to be our T and our B, so it's going to be TB. And then we are going to have the following. We're going to have this, and we're going to have this. It's a rough sketch of what we have, and then our T is going to be alpha. And then over here, yeah, we don't have any other angles at the moment. This one is going to be S. So now we have BTS, right? Triangle BTS. Now we need to put in our information. Remember that they gave us TS, or TS is equal to root 26, right? So TS is equal to root 26. And then we have the, the other information we don't have, right? Now the reason why I'm writing this down is because if you note, if we're finding the area, we can actually use the area rule. The area rule states that we have the area, in our case over here, it's going to be triangle BT. Okay, let's just do this, right? The area of a triangle is going to be equal to a half multiplied by A, or let's, so we're going to say A times B multiplied by the sine of our angle in between, right? So which means in our case here, this angle should be basically, so let's say for example, this is going to be A, this is B, this angle C has to be in between those sides over there. So that's what we need to note over here, right? So I'm going to keep this here actually. So we have angle C, and then this must be A and B. So now we just need to plot our information in. So what we are going to find is the area of triangle BTS, and then this is going to be equal to a half, and our A, let's just say that our one side is going to be root 26 multiplied by our B, which we are going to call BT, right? That looks like beta. So BT multiplied by our sine of our alpha, right? And now, okay, let me not put the information in yet. So we're gonna have TS. There we go. So we are missing BT, right? We know that our alpha is actually just equal to 37,88, right? Which we have over here. Sorry. So what, in order to find BT, let's look at the information we have. BT, our BT over here, right? So let me just add this just quickly over here, just so I can explain it to you. So we have M, which is the midpoint. Remember that that is the midpoint of B and T. If we are looking at the diagram over here, we can see M is the midpoint. So because of that, we can say that BT, right? We actually know the most information for MT, right? So we have the coordinates of MT over here. So we can actually say that we are going to find MT, and then after we find MT, then therefore we can say that BT is going to be equal to 2 times MT. Because remember that this distance, once we find that over there, it's going to be the exact same as that distance. So therefore, that is what makes this true to us. And our reason is going to be, okay, let's just work with this quickly, and then I'll explain, and then I'll give the reason. So first of all, let's find MT, and then you'll see where I'm going with this. So we have MT over here is going to be equal to, and then we have the square root, right? Because we're trying to find the length of MT. So we use the information we have. We have M is going to be 1 and 2, and T is 3 and 6. So M being 1 and 2, and then T is 3 and 6, right? And then we're just going to call this over here set 1, and this set 2. Therefore, this is going to be x1, y1. This is going to be x2, y2, right? And now, over here, we're going to have y2, which is going to be 6 minus, and then our y1, which is going to be 2, all squared, plus, and we are going to have x2, which is 3, minus our x1, which is 1, all squared. And now over here, we're going to have MT equals 2, and over here we're going to have 6 minus 2, which is equal to 4, so that's going to be 4 square, plus 3 minus 1, which is equal to 2, that's 2 square. And then we can just close the third over here. Then we have MT, which is going to be equal to the square root, and we're going to have 4 squared, which is 16, plus 2 squared, which is 4, and therefore this answer would actually be the square root of 20. Okay, so therefore mt is equal to square root of 20, and remember what I said over here? bt is equal to 2 times mt, and this is the reason why. So bt is equal to 2 times mt, so it's 2 times bigger than mt. That's what we're trying to say basically. mt is half, or you could even write it like this, right? You could say that mt is equal to half of bt, if that would make sense. I think that one makes a little bit more. Okay, both of them make sense. I don't know what I'm talking about. And obviously you have to multiply both sides by 2, right? Such that these will cancel out, and then you'll be left exactly with what was here over here, right? So let's stick with that one there. Okay. So the reason that we use for this one goes as follows. We know that BT is the diagonal of the parallelogram, right? So therefore, why does it keep going back there? So therefore, and plus, remember, we're using from the information over here, and just pay attention to what I'm going to call it right here, right? The diagonals of the parallelogram bisect each other. Okay, now you see this is actually the closest reason we can get to proving that M over here, right, is the midpoint of these of BT. And the reason why I'm trying to use that reason is because we're using the properties of the diagonals, and we don't have much. We only have 2 properties of diagonals, one with the sides and one with the angles, and we're using the one with the sides, and that one states over here that the diagonals of the parm or parallelogram bisect each other. So that's the property that we do use. Now we can just substitute. We have BT is going to be equal to 2 multiplied by root of 20, which we can actually just write as 2 root 20. Okay, now that we have BT, remember, now we have BT, and we have TS, and we have sine alpha. So therefore now we can find the area. So it's going to be the area of triangle BTS is just going to be equal to half multiplied by our BT, which is 2 multiplied by the root 20, multiplied by our root 26, which we had as TS. Yes, TS was root 26, and sine of alpha, it is really acting crazy here. Sine multiplied by sine of alpha, alpha is just equal to 37,88 degrees. Just quickly verify here, 37,88 degrees. And if we put that all into our calculator, we get the following answer over here. So there, jeez, going crazy. So therefore, the area of triangle BTS is going to be equal to, you'll get an answer of 14,001, and which we can just basically approximate to 14 units square. Remember your square, because it's the area in this case over here. Now we move on to the final question. Okay, so the last one is also kind of a tricky one here, but it's not that, actually, you know what, it's actually not that bad. Determine the perpendicular height of the parallelogram if TS is the base, right? So they're saying if TS is the base, so they're talking about this side over here. So if we were to look at it like that, right, we were to see it as, we will have TS over here, and then we have the other sides like this. This would be our parallelogram upwards, such that we have TS over here as the base. Okay, so TS over here. And then we have, it is going to be B and then H, right? So that is our parallelogram. So we know that TS is going to be the square root of 26, right? The square root of 26. And they say that we need to determine the perpendicular height, which is that. This is the perpendicular height. Now, what formula do we use in order to determine the perpendicular height? Well, obviously, we need to use the formula for the area of the parallelogram, which we know that the area of a parallelogram is going to be equal to the base multiplied by the perpendicular height, right? Where we know that the base is going to be TS, so that's just going to be equal to root 26 multiplied by our perpendicular height that we want to find. And the area of the parallelogram, the area of a parallelogram goes as follows, right? We know what the area of this triangle is, right? And that from that information, we know that the other triangle here, right, the one that we didn't find the area for, is basically exactly the same as the area that we have determined because of the properties of the parallelogram. So essentially what I'm saying over here is that, okay, let me just change this back over here. So essentially what I'm trying to say over here is that if we look at it the way I just showed you right now, is that let's say we have this diagonal here. I'm just trying to say that this area is obviously going to be the same as this one because it's a parallelogram, right? So therefore, what we're going to be saying is that the parallelogram, the area of the parallelogram, is 2 times the area of triangle BTS. So let me actually write that much more neater. Triangle BTS. Remember that we determined triangle BTS, which was 14 units. So that's what I'm trying to say, right? You can see all of these questions, all of these answers link up to the next one. Then we can substitute. This is going to be 2 multiplied by 14 units, which is equal to, units square. And this is 26, root 26 multiplied by the perpendicular height. Now we can just solve for the perpendicular height. We're going to divide both sides by root 26, such that these will cancel. And therefore, we will have the perpendicular height of the parallelogram equal to 2 multiplied by 14. So it's going to be 2 multiplied by 14 all over the surd of 26, which is going to give us an answer of, let's say, approximately 5,49 units. And it's just going to stay as units.